Put your finger next to a marble on the table. Now imagine crushing the entire Earth until it fits inside that marble. The oceans, the mountains, every city, every hospital room, every kid staring up at the moon. All of it, squeezed into a ball about 9 millimeters wide. Not 9 miles, 9 millimeters. At that size, something snaps. Not the Earth, the rules. Light tries to leave and fails. Gravity stops being a gentle pull and becomes a one-way door. Time starts leaning inward, like water tilting toward a drain. And here's the part that should bother you. The strange thing isn't that physics breaks at a black hole. The strange thing is that, right up to the edge, physics works with terrifying accuracy. The place where explanation is supposed to die behaves like the universe left a ruler on the crime scene. Human engineers need 3 warning labels to keep an elevator from killing somebody. The cosmos folds light into a flawless one-way trap and apparently calls it Tuesday. So why does the strangest object in space, the place where our best theories start coughing blood, still obey a border so clean we can calculate it on paper? Convenient, isn't it? Take a stretched bedsheet and drop a bowling ball in the middle. The sheet sags. Roll a marble past it and the marble curves. Not because something grabs it, but because the floor under it is no longer flat. That's gravity in kid language. Mass bends the stage and everything else rolls across the bend. Now make the bowling ball heavier, heavy enough that the sag becomes a funnel. The marble stops orbiting and starts falling. Make the funnel steeper still, until even light, the fastest thing the universe allows, can't climb back out. That edge has a name, the event horizon. It isn't a wall, it isn't a surface you could touch. It's a line in space where escaping stops being hard and becomes illegal. And here's the number that should not exist. The speed you'd need to escape that edge is exactly the speed of light, not approximately, not close enough for physics. Exactly the one number the universe has declared the absolute ceiling, and the black hole's door is calibrated right to it. In 1916, a physicist named Karl Schwarzschild was doing the math from the trenches of World War I between artillery calculations with shells landing around him. He took Einstein's brand new equations, published just weeks earlier, and found something hiding inside them, a radius, a clean mathematical border wrapped around any mass. Einstein wrote back, frankly surprised an exact solution existed at all. Random processes rarely hand you exact solutions. Crush our sun, 700,000 kilometers wide, down to a ball about 3 kilometers across, and it becomes one of these. At the center of our own galaxy, a region called Sagittarius A star packs 4 million suns into a space smaller than the orbit of Mercury. 1 year after Einstein gave us a new language for gravity, that language coughed up a monster with a measurement tag on its ankle. We call that prediction. Fine. But prediction this sharp usually means something has been cornered. Now stop. Everything you've been told says a black hole is a chaotic, ravenous beast tearing through the dark, swallowing solar systems like loose change down a grate. It's the opposite. A black hole is the most mathematically perfect macroscopic object in the universe, perfectly spherical. And it has only 3 properties you can measure: mass, spin, and electric charge. That's the whole list. No mountains, no weather, no messy continents. The most violent thing in existence is also the cleanest. A blind explosion from the Big Bang doesn't usually leave behind flawless spheres that quietly anchor 100 billion stars. And then there's the spin. Everything in the universe turns. When a giant star collapses, it does what a figure skater does, pulling her arms in. It spins faster, violently faster. A black hole drags the fabric of space around itself like a twisting wet towel at a fraction of the speed of light. But there's a hard limit baked into reality. Spin a black hole too fast, and its horizon, that protective edge, would tear open and expose what physicists call a naked singularity. Raw, unregulated infinity bleeding straight into our universe. Cause and effect would shatter. Imagine a glass exploding into 100 pieces before you let go of it. That's reality coming apart. So how often does that happen? Never. As a black hole feeds and spins faster and faster, it climbs to 99.99999% of the limit, and then it simply stops. The radiation pushes back on the infalling gas, and the system caps its own speed. No central computer, no engineer at a console, a hypercar engine that throttles itself microseconds before it detonates, with zero software installed. NASA spends billions keeping metal rockets from rattling themselves apart in the upper atmosphere. The cosmos builds an infinite density blender, spins it near the speed of light, and balances the rotors on the first try. For a meaningless void, it has a remarkable sense of boundaries. It gets worse at the edge. In 1974, Stephen Hawking did something that had no right to work. He took the two theories that famously refused to share a room, quantum mechanics, which rules the unimaginably small, and general relativity, which rules the unimaginably massive, and forced them to operate at the same spot, the event horizon. Every attempt to combine them for 70 years has produced nonsense. The number of Nobel Prizes for successfully unifying them is still 0. Hawking ran the calculation anyway, and out came a temperature. An exact calculable temperature, built from 4 constants pulled from 4 separate corners of physics: gravity, quantum theory, thermodynamics, and the geometry of space. 4 numbers that have no business being in the same equation, meeting at one boundary to produce one precise value. For a black hole the mass of our sun, about 60 billionths of a degree above absolute zero, you can calculate it to as many decimals as you want. 4 constants, 4 territories, 1 number. Randomness, apparently, sat the thermodynamics exam without studying and aced it on the first try. And 1 year earlier, in 1973, 3 physicists, Bardeen, Carter, and Hawking, wrote down 4 laws of black hole mechanics. They map, almost insultingly cleanly, onto the laws of heat and engines and refrigerators. The thing that supposedly destroys all the rules quietly obeys the same rulebook as the steam rising off hot asphalt. Nobody wrote that correspondence in by hand. It fell out of equations built for other reasons. Then we photographed it. In April 2019, the Event Horizon telescope turned the whole Earth into a single virtual lens and captured the first image of a black hole in galaxy M87, 55 million light-years away, 6.5 billion times the mass of the Sun. A glowing ring around a dark center. Not random glitter, the exact silhouette general relativity had predicted. Light bent, trapped, and wrapped around the edge of no return. Throw a coin across an ocean and find it later, balanced on its edge, on a kitchen table. Then have someone shrug and say, "That's just what loose change does." That's not an explanation, that's a refusal to be embarrassed. In 2015, LIGO felt 2 black holes collide more than 1 billion light-years away, a ripple in the shape of space itself, stretching its detectors by less than the width of a proton. And the signal had a shape. It rose, it chirped, it ended, matching, beat for beat, the math of 2 black holes spiraling into one. Even the violence had grammar. So picture what we'd do with the control panel. A spinning black hole can pour out energy through something called the Penrose process, up to about 20% of its entire mass turned into usable power, drawn straight from the spin of space. Our best fusion reactors, after decades and billions of dollars, still can't run for a clean minute. When CERN first switched on the Large Hadron Collider in 2008, people filed lawsuits, terrified we'd accidentally brew a black hole in Switzerland. The universe makes them by the billion and uses them to hold galaxies together. And none of it is fragile in isolation. It's welded. Change the speed of light, and the size of the horizon changes. Make gravity a little weaker, and stars never cook the carbon in your cells or the iron in your blood. A little stronger, and the universe burns through its structure like paper. Every layer has to agree at once, or there's no picture at all. Not poetry. Inventory. For something with no plan, it keeps showing up exactly when the patient needs it. So let's lay out the crime scene. The one place in the universe where physics is supposed to fail is the one place 2 enemy theories finally agree. The most violent object we know is the most perfectly shaped. Its door is calibrated to the exact speed of light. Its spin caps itself a hair before it would tear reality open. Its temperature falls out of 4 unrelated constants. Its laws are the laws of a steam engine. And when we finally looked, the silhouette matched the math. Every one of those could be a coincidence. Stack them, and coincidence starts to sound less like an answer and more like a word we use so we don't have to say the other one. The universe didn't just leave a ruler on the crime scene, it measured twice. So here's the question. This thing leaves sitting in the dark, and I genuinely like a better answer than the one we keep repeating. If nothing aimed it, who calibrated the one place where everything should have broken?